Here we'll describe orographic precipitation as a warm, moist air mass is going to be forced upward by this mountain. So this pocket of warm, moist air is going to be moving because that's the direction of the wind. Would say the westerlies are dominating that wind pattern, for example. And so eventually that warm, moist air, because the mountain's there, because topography is there, is then going to condense, cool, and fall back down as rain. So the effect then is you're going to get an area that's quite lush on one side of the mountain. Eventually this pocket of air will reach the top of a mountain or top of an upland surface and then eventually continue on the other side. The wind pattern continues to move that pocket of air. Eventually that pocket of air will move along, and essentially the simplest way I can describe is it spews out all of its fluids. So it spews out all of its fluids on the one side, but then as it descends on the other side, it becomes quite dry, resulting in a rain shadow effect on the leeward side of a mountain. Here's an isoline map that shows precipitation. So the areas with the highest precipitation are in blue and purple, and places with the least amount of precipitation are red, yellow, and orange. And what you notice is there's definitely a clear pattern here of precipitation along the Pacific coast, whereas further inland it's quite dry. And key to understanding that is the fact that right through here is what they call the Cascade Range, a mountain range. And so this mountain range creates a situation where it's wet on one side and quite dry on the other. So we're going to look at two places that are on opposite sides, the first being Seattle, Washington, the other one being Walla Walla, Washington. Here's an image from Seattle, and Seattle is known for their all-day kind of drizzly rain situation. When we think about why coffee is so popular here, because they're not growing the coffee there. It's popular because it's pretty much all day long dreary, and coffee helps to keep you awake at 3 o'clock in the afternoon when it looks just like it did at 9 a.m. And Seattle's known for its dense pine and evergreen forests, which we find here. And so the forests, once again, are fueled by a good amount of precipitation that occurs on the windward side of the Cascades. However, on the opposite side of the state, it looks completely different. And so, of course, this is a field in which has been altered by humans, but nonetheless, it gives you an indication clearly of the amount of precipitation that falls here in Walla Walla, Washington. And we'll do a quick pop quiz. Where can you see orographic precipitation in action? So think about where you can see upland areas and their influence on precipitation levels. Let's go ahead and pause it. And then right now you can now see the results.